Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to go through an example of secant, cosecant, and cotangent, given the same triangle that we used in our example for sine, cosine, and tangent. And I want to go through calculating these in two different ways. The first way is going to be directly given their definitions, and the second is going to be using that inverse relationship with sine, cosine, and tangent. So let's go ahead and crack on here. We have theta again, and we have phi again. So I'm going to go ahead and make that same table we made last time with theta and phi. And again, we're calculating the secant, the cosecant, and the cotangent, right? And so what I want to do is I want to quickly redo the definitions here for secant. So secant is going to be hypotenuse. Let's make that a little cleaner here. Is going to be hypotenuse over adjacent. Right? So let's talk about theta first. So for theta, right, this angle right here, the hypotenuse, again, is always the angle that is opposite 90 degrees. So in this case, our hypotenuse is 5. And our adjacent, again, that's the side that is touching the ankle, the ankle, that is touching the angle. So in this case, our adjacent is going to be 4. Right, so our secant in this case is 5/4. So now I want to go get the same answer in a slightly different way. And what I want to do is I want to remember the fact that secant is also equal to the inverse of cosine. Right? And so if we remember that cosine is equal to, right, so adjacent over hypotenuse. Right, so if we just quickly run back and calculate cosine, right, the cosine of this angle, adjacent is 4, hypotenuse is 5. So this is going to be 4/5. We know that the secant is equal to the inverse, so if we do 1/4/5, right, that is the same as saying 5/4, which is indeed the same answer here. Right, so there's two ways we can calculate it. We can calculate it directly by remembering that it's this, or we can remember SOHCAHTOA and then remember to just flip it to get the secant. Right? Hopefully that makes sense. Let's go through the next trig function here, which is going to be the cosecant, or CSC. So the cosecant here, right, is going to be hypotenuse again over opposite. Right, and so for angle theta here, right, the hypotenuse is still 5. So our hypotenuse is going to be 5. But then again, now we're talking about opposite. The opposite side is the side that is not touching the angle. So in this case, our opposite side is going to be 3. So our cosecant is going to be 5/3. And we can do the same thing we did with secant related to cosine. We can relate cosecant to sine. So if we remember sine, right? Sine is the so that's opposite over hypotenuse, right? And then we know this is equal to 1 over the sine. So if we remember sine, opposite over hypotenuse, right? If we look back at our triangle here, our opposite side is still 3, right? That hasn't changed. And our hypotenuse is still 5, that hasn't changed. So if we do 1/3/5, right, that's the same as saying 5/3. And again, we end up back where we started. Finally, I want to do the cotangent. All right, cotangent, right, the cotangent is going to be adjacent over opposite. So for theta, right, our adjacent is going to be this side 4 here. And our opposite is going to be this side 3 here. So 4/3, right? But we also know again here that the value of cotangent is the same as the inverse of tangent. So if we have tangent, right, is equal to opposite, again, this is the TOA, so opposite over adjacent, right, opposite over adjacent. So again, our opposite is 3, and our adjacent, which is the side that's touching the angle, is 4. So our tangent here is 3/4, and so cotangent is the same as saying 1 over 3/4, and that's the same as saying 4/3, which matches up quite nicely. So you can see here, based on the example with theta, that there's 2 ways we can calculate it. Directly from remembering these relationships between the angle and the sides, or by remembering SOHCAHTOA and then remembering which one you inverse to get to secant, cosecant, and cotangent. What I want to do is I want to scroll down and give us a little bit of room here, and I want to go through the same process for phi. So that way you get another sort of review, and you also can see how the values change. So let's talk about phi. Let's talk about phi in relation to the secant. Let's do secant of phi. Again, it's hypotenuse over adjacent, right? But now we're talking about phi. So it's going to be using a different set of angles, right? Hypotenuse is always going to be 5, so we have 5 here. But what side is adjacent to phi? The side adjacent to phi is the side that is touching phi, and the side touching phi is 3. So 5/3. And again, we can do the same thing by relating it to cosine, right? Cosine is adjacent over hypotenuse, right? And so again, we use the same numbers. Adjacent side is 3, and the hypotenuse is always going to be 5. So if we do that, and then we know that the secant is 1 over, so 1 over 3/5 is the same as saying 5/3. So hopefully that makes sense. We get the same answer both ways, and we can actually go ahead and add 5/3 to our secant value of phi. Okay. Let's do cosecant. Right, again, cosecant is going to be hypotenuse over opposite. So the hypotenuse of phi is again going to be 5 because that doesn't change. But the opposite, right, this is the side that is not touching phi, which in this case would be 4, right, because this side here is not touching phi, so 5/4. We can do the same relationship again with sine, right, because cosecant is the inverse of sine. So we have sine, right, that's the so that's opposite over hypotenuse. Right, and so the opposite again is still 4, right? We're still looking at the side that does not touch phi. And the hypotenuse is still 5, right? Because that's the side that's opposite the 90-degree angle. And then if we do 1 over 4/5, right, that is the same as saying 5/4. So we get the same answer in both cases, and we can add cosecant of phi to our table up here. Okay. So the last one we need to do, and hopefully we have room without going too crazy, is the cotangent. So cotangent is adjacent is opposite. Sorry, adjacent See, I'm even screwing myself up here. Cotangent is adjacent over opposite. So again, we're talking about phi. So the adjacent side for phi is going to be 3. The opposite side for phi is going to be 4. Right? And again, we can do the same thing here with the relationships with our original 3 functions. The cotangent is related to the tangent, which again is the TOA, which is opposite over adjacent, right? TOA, tangent opposite over adjacent. So we're going to look at phi one more time here, and we're going to say the opposite side is still 4, right? That hasn't changed. And the adjacent side, right, the side that's touching it, is still 3. So if we do 1 over 4 over 3, that's going to give us a value of 3 over 4. Right, again, same thing in both cases. So hopefully seeing these 2 examples really drills into your head both the equation of the actual trigonometric functions, but also how they relate to our previously defined functions. And in my personal opinion, I find it easier to remember SOHCAHTOA and then work back to secant, cosecant, and cotangent than it is to just remember these, as you could see by my slight slip with cotangent. Right? But again, either way works. You end up at the same place. So hopefully this makes sense. If any of this was confusing, I encourage you to pause the video, go back, rewatch the part you're confused about, maybe go back and rewatch the previous video if you're really struggling with these new functions. And as always, please reach out. Thank you.